Jane, a grocery store owner, selects 40 mangoes out of a batch of 800 mangoes to assess whether the mangoes sold to her are good. All the 40 selected mangoes turn out to be good, and Jane concludes that the whole batch is good based on the results of the sample. Jane, however, bought the mangoes from a dodgy supplier who placed the good mangoes on the top of the container while placing the bad mangoes at the bottom. Jane unfortunately picked the sample of 40 mangoes from the top of the batch. Based on the above, we can conclude that the sample was not a representative of the whole population. To minimize this risk, auditors tend to use statistical methods that include the use of randomly generated numbers to select the sample. The first statistical audit sampling technique is referred to as random sampling. Here, each unit within the population has a chance, mostly equal chance, of selection. The method generally uses randomly generated numbers using a software to select the sample to be tested. This ensures that there is no conscious or unconscious bias by the auditor in selecting the sample. So what is conscious or unconscious bias? Let's look again at our example relating to Jane. You will recall that Jane selected 40 mangoes from the top of the batch, which led her to wrongly conclude that the 800 mangoes were good. The reason why Jane only selected the mangoes on the top of the batch was because she could not see or reach those that were at the bottom. She therefore subconsciously introduced a bias in how the samples were selected. If Jane had used random sampling, each mango would have had an equal chance of selection. The second statistical method is systematic selection, which involves selecting every nth sampling unit within a population, with the interval determined by dividing the population by the sample size. Going back to our example relating to Jane, the population size is 800, while Jane is only after a sample of 40 mangoes. To get the interval, Jane would need to divide the population by the sample size. This equates to 20. This means that every 20th mango will be selected for testing. The starting point is, however, generally determined by generating a random start. If the starting point is determined to be 3, then the first mango to be selected will be the 3rd, then the 23rd, then the 43rd, and so forth, until a sample size of 40 is achieved. Auditors can also use non-statistical methods, such as haphazard selecting techniques. Here, the auditor uses personal judgment to select items. Since this method is non-statistical, unconscious bias may exist. Going back to our example, Jane applied haphazard selection when she selected 40 mangoes from the top of the batch. As we noted, the sample selected using this method may not always be a representative of the total population. To recap, audit sampling is the selection of less than 100% of the items within a population and utilizing the audit evidence gathered from the sample to make conclusions regarding the total population. An audit sample can be derived using statistical or non-statistical techniques. It is important to ensure that the sample selected is representative of the total population, regardless of the sampling method used.